Hello everyone. We are going to look at the technique, the next greedy technique topic called as job scheduling. Okay, when I'm talking about job scheduling, basically it means that you have a set of n jobs which you have to run on a computer. Each job I has a deadline di which is greater than or equal to 1. Okay, it has a deadline of more than 1 minute or a second. And every job has a profit pi which should be greater than or equal to 0. Now there is only one computer and all these jobs have to run on that computer within the deadline period. So we need to find out how many jobs can be run within the deadline period and get the maximum profit out of it. Okay, and each job, as we know it, takes 1 unit of time. That is, if you're talking about an event, it can be 1 hour. If you're talking about one specific file running, it can be considered as 1 minute, and so on. The profit that is only earned when the job is completed within the deadline. If in case you cannot complete a job within the deadline period gets over, then basically you'll not be able to earn profit for that particular job. So it's as good as when you're given projects, you're given with a deadline. So you have to make sure you are finishing your project within the deadline period. So if you finish it within the deadline period, you get the maximum profit out of it. Otherwise, the client basically may be unhappy with you and he might reduce the amount of profit that you may get. So basic concept here is to find the subset of jobs that maximizes the profit. So how best can you prioritize your jobs that you want to do to finish the maximum amount of work within a limited period of time? And that basically talks about maximizing sigma I belonging to j pa I. So this is basically called as the objective function for this job scheduling method. Since it belongs to the subset paradigm, you can also talk about greedy technique being used. Now, to formulate a greedy algorithm to obtain an optimal solution, we need to formulate an optimization measure. And this optimization measure has to be used for determining how we are going to choose the next job, each and every job, how we are going to choose. So choosing the optimization measure, we have to keep in mind, we have to use the objective function for doing so. Otherwise, we will never be able to get the optimal solution. So the next job to include, whenever you're having a job and you want to include the next job, it should always basically be included in such a way that it increases the profit, meaning it gets over within the deadline and my profit will increase. So subject to the constraint that the resulting job is a feasible solution. So if it doesn't get over within the deadline, then basically it's not a feasible solution. So to choose jobs, first thing what we can do is, because profit is the main criteria for us, we can arrange each and every job in the descending order of the profits that you can get. So order the jobs in the decreasing order of profit. So the first job that we do, since each and every job runs at the same amount of time, we can basically think of only the profit. So if I finish each job within this period of time, then basically I'll be getting the job with the most profit. I'll earn most profit, optimal solution I can get. So first thing, order jobs in decreasing order of profit. Then choose jobs one at a time as per the order and add to the solution if the solution remains feasible. Feasible meaning job finishes within the deadline. So if you're talking about a high level algorithm, you're telling initially I'm having one job. Then from the second job onwards, I'm going to check if I can complete the job within the deadline period. If the job can be completed within the deadline period, then I will add the job into my subset of jobs. So the final answer that I'll be getting is what is the subset of jobs and how much profit can I earn through this particular subset of jobs. So taking an example of job scheduling. Let's consider we have 4 jobs. The first job has a profit of 100, second job has a profit of 10, third job has a profit of 15, and fourth job earns me a profit of 27. The deadline is the first job has to get over within 2 minutes. Second job has to get over within the first minute. Third job has to get over within 2 minutes, and the fourth job has to get over within the first minute. Now, the first step over here is, if I want to apply greedy approach, arrange everything in descending order. So if I want to arrange this in the descending order of profits, first is job 1, okay, which is followed by job 4, which is followed by job 3, and then job 2. So this is the order in which we are going to choose. Now when we are going to choose the first job, we have to see if the first job is within the deadline. So deadline is 2 minutes. So I can basically even try to run this within the second minute. Okay. So job 1 is added, telling it is feasible. And then I go for the next job, which is job 4. When I'm going to add the job 4, in case if I would have added job 1 in the first slot, then job 4 I'll have to add it in the second slot. But the deadline is only 1 minute. Within the first minute, it should have gotten over. So there is no way I can add 4 if it is 1 comma 4. But if I would have thought of running this job in the second minute, then basically I can run this job in the first minute and it becomes a feasible solution. So job 4 can be added into a feasible solution only if I'm scheduling it as fourth job followed by first job and not vice versa. Then I go for the next job, which is 3. Now 3 has to get over within the deadline of 2. But within the deadline of 2, I'm running the first job, so there is no way I can include 3. So it becomes an infeasible solution. And that way, even when I want to add fourth job 2, it again becomes an infeasible solution. So the maximum profit that I'm earning is 27 plus 100, which will be 127. So time complexity, if you are thinking, it will basically, for evaluating a feasibility set, it always goes to n factorial. Now, the same thing, if I just try to show you step by step, we are choosing the first job. Okay, so let's go into the way in which we can schedule it so that we can get a feasible solution all the time and not this kind of solution. So when I'm taking the first job, I find that the maximum deadline is 2 seconds or 2 minutes. So basically I can put it in the second slot. Okay, once I put it in the second slot, then I go for the next job, that is my job 4, and this job 4 has deadline of 1 minute, and this 1 minute, this particular slot is free, so I can basically add that job 4 in the first slot, and thereby I get job 4 followed by job 1, and I'll get the maximum profit of 127. So then if I want to add job 3, I find a profit of 15, deadline is 2, but second slot is already filled and first slot is also filled. So there is no place for me to fill job 3 anywhere. So thereby it becomes infeasible. Okay. But in case if this particular slot were free, then I could have added over here as well. Okay. So thereby, this is how you do your job scheduling algorithm. So if I want to consider it into a detailed algorithm, basically what we do is first we are arranging it in the decreasing order of the profits. After you arrange it in the decreasing order of the profit, I'm going to make all the slots from 1 to n as false. Okay. N will be the highest deadline that I am having, or the number of slots that are available before the deadline. Now, for I equal to 1, I less than or equal to n, what I'm going to do is, I'm going to check. So for each and every slot, I have to fill each and every slot. So that is why I'm going to check each time. I'm going to take the deadline of that particular object, the first object, I'm going to take the deadline of that particular object as the position. And then I'm going to check if the slot at that particular object is free. So if you would have seen this particular example, initially my first job has deadline of 2. So my J value is 2. I'm checking if this particular slot is free. It is free. So that is why I'm going to add this particular job in this particular slot. Okay. So I can add the job and I can make the slot as true. I'm incrementing k, telling I've included the number of jobs that I've included is 1. Then again I'm going for the next job, and I'm checking for the deadline. This time the deadline is 1. So again I'm going to check if the first slot is free. The slot is free, so it gets added automatically, and thereby I can get the maximum profit. Now in case if this particular deadline would have been 2, then it would have come here, it would have checked if this slot is free. This slot is not free, so it is false. So when it is false, what it will do? It will decrement j. So j now becomes 1. So when j becomes 1, again it checks if slot of 1 is false, it is true. Okay, because slot of 1 is empty. Thereby it will make that particular slot as true, and it will include that particular job. So remember, if you are having jobs with same deadline, you can always reduce the deadline and try to fill in if it can provide me with maximum profit. So this concludes the job scheduling algorithm. So I'm giving you guys 3 problems. One real-time example wherein you can talk about a college fest starting at 9 o'clock. There are number of available events below to participate, and each event takes 1 unit of time, that is 1 hour. Okay, each event finishes in 1 hour, and each event has different award values. That means some events might be giving me 1,000 rupees, another event might be giving me 5,000 rupees. Like that, they have different award values. So, and each event has its own closing timeline. So if you can see, mimicry event has to get over before 12 o'clock. Drama has to get over before 11 o'clock. Painting before 12, dance before 10, jam before 11, and singing before 10 o'clock. And each of these events have different prize money. So if you consider this, the event starts at 9 o'clock. So I can think of writing the deadline. So this deadline part will not be given to you. You should basically be making up the deadline. Since the event starts at 9 o'clock till 12 o'clock, meaning it is 3 hours. And each event we know takes only 1 hour. So deadline is 3 hours. For drama it is 2 hours, painting 3 hours, dance 1 hour, jam 2 hours, and singing 1 hour. Now you need to see which all events can you go and participate in, such the way that you can get the maximum award. So what is the maximum award you can get? Let's say if you are going to win each and every event that you will participate in. Okay, so this is one problem which you have to do. The second problem that you have to do is you are being given 7 jobs. The profit of each and every job is given as below, and the deadline for the jobs is also given here. So you need to basically find out the number of jobs that can be completed with maximum profit. So what's the first step? Arrange it in descending order of the profit and write that particular table. Okay, so you need to write the same table again by arranging it in descending order. So if you're giving the job as 1, 2, 3, 4, 5, 6, 7, when you arrange it in descending order, you should basically write it as 7, 3, 4, and so on. Okay, so like that, the job name you have to write, profit and deadline are in the descending order of the profits. And then you can basically proceed further to the next step of choosing how many slots are available to finish within the deadline and how you're going to place each and every job. Okay, same way for this also, you have 7 jobs with different profits. You need to find the maximum number of jobs that can be completed with maximum profit. So this ends your job scheduling algorithm. Hope you understood.